Okay, so we have a simple problem here that it says there are two, this is a hollow cylinder. That's a disc instead of cylinder. And then smaller one has a radius of 125 mm. And then the bigger one has a radius of 250 mm. Then the thickness of this one is, in this way, it is 10 mm. And the density is 8000 kg per meters cube. What is the mass moment of inertia about point O? You see, the point O means that this will be an axis passing through the point O. Okay, this axis. So let's call it as IO, means that then the mass moment of inertia passing through point O. But we also have, so what we will do is that, so this includes two problems together. One, it is a composite body. I will tell what a composite body is. The other thing is that it includes the parallel axis theorem that we talked about. Okay, so let's firstly understand that we are looking for the I value and then check table. This is the first thing that we have to do. And then when we come back to the table, we don't have the case for this one. We have only the case that is the thin ring, but that's not the thin ring. Okay, so but what we have in the table is that this one. We have the thin circular disc. That is what we have. This one is also thin because this one is 10 mm. So what we will do, we will apply the superposition principle. What it means is that you add or subtract the body. Subtract means it is whole. So in this case, you can see that this is the body that we have. The body is like full one minus this one. You see, we subtract when it is a whole, so we will subtract it. So it means that this one will be the I1 and this one will be that I2 and then this one will be I3. So from here, I1 will be equal to I2 minus I3. Okay, let's start from the I2 value. But in all of these cases, I will find with respect to central axis and then use parallel axis theorem. So and the central axis means just this one. This will be the central axis. Okay. Similarly here. Similarly here. Okay. This is the central axis. Okay, now let's try to find it. Firstly, the I2 value. And then let's go back to the table here. With respect to the central axis z, that is 1/2 mr squared. 1/2 mr squared. That will be similarly for the second one. What is m then? M will be the density into the volume. Okay, density is 8,000 times the volume is the area of this one, which is pi r squared times the thickness. That will be 8,000 times pi times 0.250 squared times the thickness, which is 0.01. Okay, that will be the mass of this object. If you do the calculation, 8,000 times 3.14 times 0.25 times 0.25 times 0.01, 15.7. From here it will be 1/2 times 15.7 times 0.25 squared. That will be times and then 0.491 kilograms meter squared. Okay, then there comes the I3 value, which is exactly the same stuff as here. That will be 1/2 m into r squared, and that will be 1/2 into 8,000 times the pi times 0.125 squared times 0.01. This part is the mass, which is rho into v, and then times 0.125 squared. Okay, let's do this calculation then. Okay, actually this part makes 3.93 kg times 0.031 kilograms meter squared. That's I3 value. Then I1 will be I2 minus I3 value. That will be 0.491 minus 0.031. That will be 0.460 kilograms meter squared with respect to the central axis. But the question says that find with respect to the axis passing through the point O. So we will use the IO. The parallel axis theorem says that if you move a little bit distance off the axis that you want, you can use this equation. So that will be I passing through point O will be I1 plus mass into distance squared. Then I1 plus mass into the distance is from here to there, this distance, which is 0.25. Okay, this m, you have to be careful, is mass of the hollow cylinder. So we have the I1 value, actually this is squared. The I1 value is 0.406 plus the mass will be 15.7 minus 3.93 times 0.25 squared, and then it will be that 15.7 minus 3.93 times 0.5, 0.25, then plus 0.460. Okay, 1.2 1.2 kilograms. Okay, that's all. Thanks for watching.